This is question number 4 from section 2 of the review quiz. So now we're looking at volume and mass. So this is our given, and this is our wanted. It also tells us that it's a synthesis reaction between oxygen and magnesium to make magnesium oxide. So of course, the first step we should always take is to balance that equation. So we know that we have oxygen gas. Remember that oxygen gas is always O2, and magnesium are going to synthesize magnesium oxide. Magnesium has a charge of +2. Oxygen has a charge of 2-. So these balance each other out. We don't need to add any subscripts. But now I need to look at my equation. It is not entirely balanced. I have 2 oxygens. I only have 1 oxygen. So I'm going to throw a 2 in front of this, which means I also have to add a 2 in front of my magnesium. Now I have a balanced equation. And I can move on to my given. So I have 3 grams of magnesium. And of course, my first step is always to get to moles. And I have grams right now. So I want to get rid of those grams. I want to turn those grams into moles. I'm going to put grams on the bottom, moles on the top. To get rid of grams of magnesium, I need to use the molar mass of magnesium. I look at my handy dandy periodic table, and the molar mass of magnesium is 24.305. And the molar mass on the periodic table always tells us how many grams are in 1 mole. So now that I have moles of magnesium, I can flip my chemicals away from the magnesium. Sorry, that's my cat. Flip my moles away from magnesium into oxygen because I'm given magnesium, but I want oxygen. I want to get rid of magnesium. Right now it's on the top. I want it to go away. I'm going to put it on the bottom. I don't want magnesium. I do want oxygen, so I'm going to put oxygen on the top. Before I can call this conversion factor done, I need to add the coefficients from the balanced equation. Magnesium has a 2. Oxygen has an invisible 1. So now I've gotten rid of magnesium. I'm left with moles of oxygen. I don't want moles of oxygen. I want the volume of oxygen. We measure volume in liters. So I'm going to get rid of my moles by putting it on the bottom. Moles on the top and moles on the bottom are going to cancel out. I want to turn my moles into liters. I know that there are 22.4 liters in 1 mole of an ideal gas at STP, and we are assuming, according to our question, standard temperature and pressure, or STP. I look at my labels. All I have left are oxygen and liters. Liters are volume. Oxygen gas is exactly what we want. So I'm going to use my calculator. I'm going to do 3 times 1 times 1 times 22.4 divided by 24.305 divided by 2. The other option is 3 divided by 24.305 times 1 divided by 2 times 22.4. And either way, we should get 1.4 liters of oxygen.